In this section, 3.3, we're going to be talking about multiplication and division of whole numbers. So, like in the previous section, I know that you guys are all familiar with how to multiply and divide numbers, but it is important to go back over, especially the properties that are associated with multiplication and the proper terminology. So that's really important. So we're going to focus on that, and we're going to talk about it because I want you guys to be, using proper terminology with your kiddos. So, first of all, I talked about before, there really is only addition in all of our number system and the things that we do with it. Really, the only operation that exists is addition, and everything else is kind of a manipulation of that, or um, well, manipulation is the best word I can come up with, a version of it. But if we were to say, you know, th- if you needed to add 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3 300 times, you would get so frustrated before you were finished that you just would stop. So this is where multiplication comes into play, and it's a shortcut for doing all that addition. Instead of adding 3 to itself 300 times, we can just say 300 times 3, and it's much easier, much quicker to do. So we can thank the mathematicians a long time ago who kind of put that into perspective and figured it out, and so that we had that little shortcut. Multiplication is nothing but repeated addition, but I do want you to know the parts of multiplication. So the pieces of multiplication are this: a factor times a factor equals a product. So if we were to have something like, say, 3 times 5 equals 15, then 3 would be called a factor, 5 would be called a factor, and 15 would be called a product. I do want you to know those terms. Okay, now about the properties. I know you guys have seen the properties before also, but this is important, and so I do want to talk about them for a little bit. Multiplication is a closed operation under the whole numbers. Now, we talked about what closed meant when we talked about addition. So, since addition is closed under, for as an operation, then multiplication must also be closed, because multiplication is just repeated addition. And if you'll remember, when we talked about closure for addition, that meant that we could add any two numbers we wanted to within the whole number set, and we would end up with a number that's also in the whole number set. Well, the same thing happens with multiplication. If you were to multiply any two numbers in the whole number set, you will also get as a product a number in the whole number set. So we have the closure property. We also have commutative and associative, and they are very, very similar to what the rules were for addition. Commutative, I think I said this last time, think of the very first part of the word, commute. It's like back and forth. You can multiply in any order you want to and still get the same number. So what that means is saying something like 2 times 3 is the same thing as 3 times 2. They literally change places. Now, the associative property is reassociating items. So it's not the order that changes, it's just what you are doing first. You're using parentheses to say, well, let's multiply 2 times 3 first, and then multiply that answer to 4. Or we could multiply 3 times 4 first, and then multiply that answer to 2, and we will get the same answer. Then we have the identity property of multiplication. Now, if you remember, the identity is what you do that doesn't change a number. So for multiplication, that would have to be 1. The identity for multiplication is 1. because anytime you multiply 1 times something, you get that number back. So we have that identity property. We also have a very cool property that allows us, especially when we get into algebra, to be able to do things. I mean, it would seem kind of silly, if you had something like, say, 2 times 3 times 4, or some, or 3, whatever. It would be, or like say 3 plus 4. Let's do that. If you were going to do something like this, you would supposedly, according to order of operations, you would add the 3 and the 4 first, and then multiply that to the 2. Um, but we can also distribute that 2 throughout the addition and get the exact same number. So if I were to add the 3 and the 4 first, I would get 7 times 2 would be 14. So we know that should be the answer. Well, if I were to distribute the 2 and say 2 times 3 is 6 and 2 times 4 is 8, when I add those together, don't I still get 14? Absolutely. So it's the same thing, and it doesn't help us much when we're talking about just plain numbers. But where it really comes into play is when we move into algebra and we have all the letters, and we still need to be able to multiply and simplify expressions. So that's where that comes into play. So whenever you're talking about letters, the property says if you have A times B plus C, you can distribute that A multiplication throughout the parentheses. So it becomes A times B, which is here, plus A times C, which is here. And then it also goes backwards. We talk about this as factoring, but I like to look at it as just reverse distribution. If you have AB plus AC, we can see that they both have a common A. So we can pull that out the front, and we're still left with then the B and then plus the C. So that's what I like to call reverse distribution. All right, now I said the last thing we need to talk about is division of and by zero, and then I remembered there were a couple of other things in here too. But these tend to get most people really confused, and so I want to make sure that we are very clear about division by zero and of zero. So if you divide by zero, that is a very big no-no. That is undefined. So I say the first commandment of math, there's a little poster if you ever happen to look on some teaching catalogs and stuff for some supplies for your classroom. You can see there's actually a poster that's called the 10 Commandments of Math. And the very first commandment is thou shalt not divide by zero. So that's kind of funny and nice to have in your classroom. But anyway, division by zero is undefined. And I kind of want to show you and talk to you why that is for just a minute. So I'm going to get a clean page here, and then I'll have to go back and finish up. But let's say that we had, six triangles, something I can draw out pretty easy. So 1, 2, 3, 4, 5, 6. And I wanted to do 6 divided by 2. Well, we know that 6 divided by 2 equals 3. True? So if I were to take these 6 things and I were to divide them into 2 groups, then I would have, let's see, 1, 2, 3 here, and 1, 2, 3 here. So there would be 3 in each one of those groups. True? Okay. You could also look at it, the other way. You could say 6 divided by 3 is 2. So if we were to separate them into groups of 2, then we would have 1, 2 here, and 1, 2 here, and 1, 2 here. So we would end up with, we could look at it that way also. Now, when we're talking about division by zero, So if I were to take these 6 triangles and I were to put those in 0 groups, well, how many groups would I have? It looks like I have no groups, right? But remember that the empty set is a subset of every set. We've talked about that already. So what if I have this group over here that has 0 triangles in it? And then I have another group over here that has 0 triangles in it. And then I have a group over here, and a group here, and a group here, and a group here, and so on and so forth. And I can make bigger groups or smaller groups or lots and lots of groups. They all have 0 triangles in them, right? But I still am left with 6 triangles that I have not placed into groups. How many groups could I get out of those 6 triangles? Well, I could get a whole bunch, an infinite amount. In fact, we don't have the capacity to understand how many groups that we could get out of those 6 triangles. And that's why 6 divided by 0 is undefined, because we don't have that capacity to talk about it. Now, on the flip side of that, if we talk about 0, let me put a line here, 0 divided by 6, well, I'm going to start off with 0 triangles right here. And I want to put those in groups of 6. How many groups do I have? 0 triangles. There are no, 0 groups. There are no groups of triangles that can come from 0 triangles. So that's why there's a difference between dividing by 0 and dividing of 0. So I want to keep those very clear, and sometimes that's a little bit difficult to understand and get, you know, kind of a picture of. But anyway, oh, where did my thingy go? It's got to be here somewhere. Dun, 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 dun. Let me find it real quick. Oh, my thingy here is in the way. Hang on just 1 second. Let me, I don't want my whiteboard. Oh, there's what I want. All right there. Okay, so now I'm back on track again. All right, so hopefully you have a little bit better understanding of dividing of and by 0, and you can explain that then to your kiddos, and that will help them so much. Sometimes I like to, in class, set out, like 2 or 4 or 6 or whatever pencils and start putting them into groups and talking about that that's what division actually means. And so, and then talking about putting them in groups of 0 and how many groups could I get. So that's kind of a nice visual aid for you. Okay. Also, we need to talk about something that I know that you already know, but it's something worth going over. There is such a thing called the multiplication property of 0, and this says that anything that you multiply by 0 is 0. The product of that is 0. So anytime you have 0 as a factor, the product is always 0. So that's the multiplication property of 0. And then lastly, I forgot to put actually on your notes, but I talked about the vocabulary that goes along with multiplication, and I should have put on there the vocabulary that goes with division, because that's important that you know that also. We have 3 things in a division problem. A division problem normally technically looks like something like 6 divided by 2 equals 3. Well, each one of those parts has a specific name. The part underneath the symbol is called the dividend. Dividend. The part on the outside is called the divisor. And then the answer is called the quotient. So we have dividend divided by divisor equals the quotient. Now, if we look at it in fractional form, because fraction is nothing more than just a compact way of writing division, it would be the dividend would be on top and the divisor would be on bottom, and that would equal the quotient. So I do want you to know those vocabulary terms, and they will actually be on in your exam for this section. So know the terms for addition, subtraction, multiplication, and division.